So in this video, we are going to be solving simple equations. If we have something like x plus 7 equals 11, how could we solve this equation and find the value of x? Well, to do that, we must isolate x and put x on one side of the equation. But how can we do this when you have 7, positive 7 here? We have to get rid of it, but what's the method for this? Well, the method is to balance this equation. So if we write out x plus 7 here, to get rid of the 7, we must balance the equation, and that basically means to take the opposite operation of this plus positive 7 here. So we're adding 7 here, and the opposite operation would be to subtract 7. So it's x plus 7 minus 7, and whatever we do here are negative 7. Taking away our 7 here, subtracting our 7, that must be done on this right side of the equation. So that gives us 11 subtract 7. And we must do the same operations on both sides of the equation, because if we had something like a balancing scale, let's say we have to, whatever we take away from one side, whatever quantity we take away from one side must be taken away from the other side of the balancing scale. So the same thing works here, and that will balance our equation so we don't change it. When we write out our equation, we get x equals 4. So as you can see here, we got to our final goal of isolating this x. And that's because when we're taking the opposite operations, we have positive 7 here, and the opposite operation was subtracting that 7, we get 0. Plus 7 minus 7 is 0. So that means we don't have to change anything on this side, it's just equal to 0. And now we have this x. And of course, since we have negative 7 here, we must subtract 7 here. So that's 11 minus 7, which is 4. So if we look at another example, let's say we had x minus 3 equals 10. So this is pretty much like our first example, but of course now here we had addition and here we have subtraction. But we can work it out in the same way. So if you write out x minus 3, we have to balance this equation and take the opposite operation. So that gives us x minus 3 and plus 3, since addition is opposite to subtraction. And now, since we added 3 here, we must do the same thing on our right side of the equation. So that's 10 plus 3, and that gives us x equals 13. So now let's try something like 3x equals 21. Now, in like our other examples, we're using multiplication. It's 3x. And the same thing works here. We have to balance our equation. So if we have 3x, our opposite operation would be division. So it would be 3x, and this time we would be dividing by 3. So that would give us 3x divided by 3, and we'll get 21 divided by 3, and that equals, so x here equals 7. And as you can see here, 3 divided by 3 is 1, so that's why we can end up with x here. We're not changing our equation. And unlike here where we had negative 3 plus 3 or positive 7 minus 7, these all equal 0. This equals 1 because when we're multiplying to get the same answer here, we have to get x. We have to just multiply by 1. 1 times x would give us x. So that's why here we're dividing. And now if we take something where we have x divided by 3, and that equals 36. So in this example here, we again have to take our opposite operation. So like here we had multiplication and the opposite operation was division. So here we have division and of course the opposite operation would be multiplication. So that's going to give us 3. And this will be multiplied by x times 3. So that will give us 36 times 3. And our product would be 108 of 36 times 3. And that means x equals 108. So in this example, we were dividing by 3. But what if we flip our numerator and denominator around and we have 3 divided by x, or we have another number and we're dividing x? So if I took 12 divide by x and set this equal to 4, this works a bit differently. We're still following the same method where we balance our equation and isolate our variable, but now we're using we have to divide by our variable x. So that gives us x times 12 divided by x, and this equals 4 times x. So as you can see, these two x's, they cancel out. It's x divided by x, which is just 1, so it's going to be 1 times 12, and here we have 4x. So that gives us 12, which equals 4x. And this is pretty normal. We have our 4x and we have our 12, and since we're multiplying by 4, we have to divide by 4. So this would be divide by 4, and this side would be divide by 4, and that means 3 equals x, and of course x equals 3. This here is the proper form. We always write our variable on our left side when we get to our final stage. 3 equals x is not incorrect. It's always x equals 3. So again, this follows pretty much the same method as we did before, but this time we have to multiply our variable since we're dividing a variable here, x, and that gives us 12 equals 4x. So then we just work it out like we normally would. We divide our 4 here to get x equals 3. So now let's look at some examples where we have two operations. Let's say we have 3x plus 8 equals 32. So we want to get rid of this 8 and this 3 so that we can isolate our x. So the first thing we have to do is get rid of this 8 here. So that gives us 3x, and it's plus 8 minus 8. Since we are adding here, we have to subtract the 8, so it's plus 8 minus 8, and that equals 32 minus 8. So now that gives us 3x equals 24, and we get rid of this 3 here, so it's 3x divided by 3, which equals 24 divided by 3, So now x equals 8. So now let's look at a final example where we have 5x plus 7 equals 42. And in this example, we have to find what our value of x is, and then we have to check this equation. So to do that, let's isolate x first. So we have 5x plus 7, and first we have to take the opposite operation of this. So it's 5x plus 7 minus 7, which equals 42 minus 7. And that gives me 45x, which equals 35. 42 minus 7. So now we're going to be dividing 5 on both sides. We're taking the opposite operation. So it's 5, and then this will be divided by 5. And that gives us 7. So x, 35 divided by 5, which is 7. So x equals 7. And like I said before, we're going to be checking this equation. So to do that, we must check each side, our left side and our right side, by substituting this value 7 and seeing if we get the right answer on both sides. So our first one is our left side, the left side of our equation. So that is 5x plus 7. So x here equals 7, so that gives us 5 times 7 plus 7, which is 35 plus 7, and that gives us 42. On our right side, we have 42. We just have 42 here, we don't have any variables. So since our left side equals our right side, they both equal 42. As we saw when we substitute this value and just have 42 here. So left side equals right side, and therefore x equals 7. So that concludes today's video. I hope you enjoyed it and now understand how to solve equations. And if you have any questions, please leave them in the comment section below. Thank you.